Good morning, guys. Welcome to today's lesson, May 22nd, Perfect Cubes Day 2. It's going to be a quick lesson today. We got a couple do now problems, practice our factoring, and we're also going to look at factoring the sum and difference of two perfect cubes, which we reviewed yesterday. All right, so the first do now question is 81x to the 8th power minus y to the 4th power. What does that look like to you? Is it GCF? Remember, we always check that first. It is not. Is it potentially dots? The difference of two perfect squares. And there actually is an example of dots here. So we need to take the square root of 81x to the 8th power and the square root of y to the 4th power. So what times itself gives you 81x to the 8th? What times itself gives you 81? That'd be 9. And what times itself gives you x to the 8th power? That'd be x to the 4th power. And now, what times itself gives you y to the 4th? That would be y squared. So you open up your two sets of parentheses. 9x to the 4th and y squared. 9x to the 4th and y squared. Remember, one set of parentheses gets addition and one gets subtraction. Are we done? Actually, you got to be careful here. A little trick. There's another example of dots right here. That's two perfect squares again. 9x to the 4th, right? That's a perfect square. And y squared is also a perfect square. So keep that first set of parentheses. 9x to the 4th plus y squared. Remember, when it's two perfect squares, they have to be separated by subtraction in order for you to use dots. Okay, so the first set of parentheses stays as is, and now we can open up two more sets for the next example of dots. What times itself gives you 9x to the 4th? That would be 3x squared. What times itself gives you y squared? That would be y. Right, y times y gives you y squared. One separated by addition, one separated by subtraction. You done now? Looks like so. All right. So double dots. Okay, next. So now we got a trinomial. Check for GCF first. All right, no example for GCF. All right, would this be AM or AC? It would be AC because the A value is 3, which is bigger than 1. So A times C is 3 times negative 5, which is negative 15. So we need these two numbers to multiply to negative 15 and add to the B value, which is 2. So what multiplies to negative 15 and adds to 2? Pause the video if you're not sure and think about that, but it would be 5 and negative 3, right? Because we multiply these real quick, show you the work. Yep, that does give me negative 15. If we were to add them together, okay, yep, that does give me positive 2. Okay, so 5 and negative 3, those go in your parentheses. Your first factor gets positive 5. Your next factor gets negative 3. And what do we throw in front? Not just x, it would be the A value x. So 3x and 3x. Remember, usually we can break down one of these. Sometimes we could break down both, but in this case we could just break down one. You could divide both of these by 3. Keep your first set of parentheses as is, 3x plus 5. And then your next set, 3x divided by 3 would just be x. Negative 3 divided by 3 would be negative 1. And you're good to go. All right. So guys, same lesson as yesterday. Remember what your perfect cubes are. Okay, 1 times 1 times 1 is 1. 2 times 2 times 2, right? 2 cubed is 8. 3 cubed, 27. 4 cubed, 64, and so on and so forth. And then they could also be variable terms. Remember, the exponent has to be a multiple of 3. So 3, 6, 12, 3, 6, 9, 12, 15, 18, and so on and so forth. Remember, when you factor them, the two factors, one of the factors will be a binomial, and one of the factors will be a trinomial. Okay, so it's sort of like a formula. We're really plugging in. These are formulas, or they're not technically formulas, but we kind of treat them that way because we're figuring something out. We're plugging it in, plug it in, plug it in. But remember, if it's the difference of two perfect cubes, our binomial will look like so. Right, and our trinomial, if we factor the sum, we get a very similar looking binomial and trinomial. Just got to be careful with the signs, whether it's positive, negative, whatever it might be. But it's all about identifying, guys. Identifying, is it a perfect cube? All right, is it the sum of two perfect cubes? Is it the difference of two perfect cubes? All right, so let's try out two more, and then hopefully we'll be good to go with this. All right. So, we have x to the 9th power minus 8y to the 3rd power. They are perfect cubes. How do I know that? Because the exponents are 9 and 3, right? Those are both multiples of 3. And also 8 is a perfect cube. So now we have the difference of two perfect cubes. Now, remember what the factored form will look like. If it's the difference, the factored form is a minus b times a squared plus ab plus b squared. So you'll have those, you'll have the setup, the factored form. You could see it, but just know, come Algebra 2, you'll have to memorize that when you come to a test or whatever it might be. All right, but the big question really is, what is A? What's A representing? And what's B representing? Okay, essentially it's A is the cubed root, all right, the cubed root of x to the 9th. And B is the cubed root of 8y to the 3rd power. So for A here, what times itself, so 3 times now, is going to give you x to the 9th power. That would be x to the 3rd. Because x to the 3rd times x to the 3rd gives you x to the 6th, times x to the 3rd again will give you that x to the 9th. Okay, and your b value, what times itself, right, 3 times, will give you 8y to the 3rd power, or cubed. Okay, so it's going to be 2 something, right? 2 cubed gives you 8. And then for y to the 3rd power, it would just be, the cubed root would just be y. Because y times y gives you y to the 3rd. And now it's really just a matter of substituting, guys. So we would have, for x to the 9th, minus 8y to the 3rd. A minus b would be x to the 3rd, x cubed, right? Minus 2y. Times a squared. I'd like to go off to the side for this. So a is x to the 3rd, right? Now we're squaring that. So that's saying x to the 3rd times itself, x to the 3rd, gives you x to the 6th. So that's a squared, x to the 6th power, plus a times b. So take these two and multiply them by each other. So 2y times x to the 3rd. We always put the number out front, so it would be 2. And then you could either write y x cubed or x cubed y, doesn't matter. I'm going to write 2y times x cubed. Remember, multiplication can take place in any order. All right, plus b squared. So b, we know, is 2y. Now we have to take that and square it. That's saying 2y times 2y, which is 4y squared. And you're done. So you just have to find those cube roots, right? And then substitute appropriately. Sometimes you have to take the cube root, just put it in there. All right, sometimes you have to multiply a and b, sometimes you have to square them, so you got to be careful. All right, next. We have the sum now, so we're going to practice one with the sum of two perfect cubes. So your factor form looks as so. We would have a plus b times a squared minus ab plus b squared. So 64, we need to find what the a value is. Remember, a is the cubed root. So saying what times itself will give you that 64. So a is equal to the cubed root of 64. That would be 4. Right, 4 times 4 is 16, times 4 again would be 64. And now the cubed root of x to the 21st. Really just a trick here, guys, with the exponents is really just dividing it by 3. Take 21 and divide it by 3. Okay, but this would be x to the 7th. Because x to the 7th times x to the 7th gives you x to the 14th. Times x to the 7th again. Remember, you're adding exponents would give you that x to the 21st. Okay, so let's substitute. This would be 64 and x to the 21st equals to a plus b. So 4 plus x to the 7th times a squared. A squared would be 4 times 4, so that would be 16, minus ab, so 4 times x to the 7th, which is just 4x to the 7th, plus b squared, which is x, that's saying x to the 7th, and we're gonna square that. Which, remember what that is, that's x to the 7th times x to the 7th, which is x to the 7 plus 7, 14. And we're done. Alright, guys, so remember we revisited that trinomial and the last example yesterday, like if we rewrote that. So your final answer, you probably thought, right, 4 plus x to the 7th. But let's just take another look at that trinomial if we reordered it. X to the 14th minus 4x to the 7th plus 16. All right, are there any factors of, now this looks like AM, right? Are there any factors of 16 that will give you, when you add them, will they give you negative 4? All right, not quite. It's good to check for, but if you see how those exponents have been going, right, with 14 and 7, I remember that was from our Super AM lesson. So it's good to check for that. Remember those exponents go. It's Super AM when the exponents are in like a 2-to-1 ratio, like 14 and 7, or 20 and 10, or 8 and 4. All right, so it's good to check for that type of factoring as well. All right, remember you always want to factor completely. All right, guys. That's it. A couple extra examples of the sum and difference of two perfect cubes. A great lesson to take with you for Algebra 2. Guys, I extended the deadline for this week's Delta Math. You can work on it all day today up until 10 o'clock tonight for full credit, 100%. So if you didn't get an opportunity to do that, please do so. And that's it. Have a wonderful weekend, and I'll see you on Monday.